Alright, this quick video on a current shunt that I got on Aliexpress for $27. And then this device is intended to extend the range of your multimeters to be able to read higher currents, uh, higher currents than it might be rated for. And in my case, I have a Fluke 8842A multimeter, which only goes to 2 amps before the fuse blows. And I wanted to go to a higher current values, and this seems to be a device that would enable me to do that. I've been testing it, running it through its paces, and the accuracy of this device is quite outstanding. It's giving me values of errors that are maybe 1/10% and better. So smaller than 1/10% errors. It's actually, the specs say that it's got an onboard resistor with a accuracy of 0.5%, but it's actually much better than that. And it does come with a calibration sticker. So you can see here on the front and the bottom it says 1 millivolt per amp. So what this device does is it converts the current flow through it into a voltage drop. And so it's 1 millivolt of voltage drop per amp of current through the device. That's the spec, but then they actually give you the calibration sticker, which is the actual measured value, which they do with some highly accurate multimeters back at the factory. And I'm finding that those values, when you use those to do the conversion, provide extremely accurate, current values versus that 0.5%, which is what it's specified for. So better than expected. And let me show you a spreadsheet that I put together that just measured the accuracy at various levels of current flow. So here's that spreadsheet. And I'm using a Ryden power supply as my current source, and I've taken values at 1/10 of an amp, 1/2 an amp, 1 amp, 1.5, 2, 2.5, and 3 amps. That's as high as I can go with my lab equipment. That's fine for this purpose. So basically the Ryden output setting and then the Ryden output reading. So when you set it to say 1 amp, it'll tell you what it's actually outputting. And so in this case, I've got a 1 amp output. The Ryden says 0.9998. My Fluke meter says 0.99999. I then have a error in percent of the Ryden versus the Fluke. Then I use the shunt, and I get a value of millivolts from the shunt. I convert that using that calibration conversion factor to get amps. In this case, 0.99990. And then I got the Ryden versus the shunt error and the Fluke versus the shunt error. And you can see those errors are much smaller than the 0.5%, which is what this device is specified to give you as far as the accuracy of the onboard resistor. So let me just show you one example of how I'm running those tests, and yeah, we'll go from there. So just scroll up here to my Fluke meter. And like I say, it'll only do 2 amps maximum before the fuse blows. I've got the output of my Ryden power supply. It's right here's my Ryden supply. And you can set it here. You set your output value to 1 amp in this case, and then when you actually turn it on, we'll do that. It'll tell you what it's actually outputting there in that center number, 0.9999, 0.9998. So those are the values that are going in that spreadsheet for the Ryden output. And then here's what the Fluke is reading. So 0.99998 on the Ryden, and then the Fluke is reading, this is in millivolts, so that's 1,000.01 or 2 milliamps. So it's basically 1 amp that the Fluke is showing. And now let me show you how I do it with the shunt. So I take the shunt and put the gold-plated plugs into the normal inputs for the reading voltage right there. Plug that in. Set this to volts. Set it to auto. Offset is 0 already. And now I'll plug in my probes from the output of the Ryden supply. Stick that in. Once again, we're reading volts DC. Make sure it's offset to 0. And now we'll turn this on. And the Ryden is reading that 0.9998. And the Fluke is reading 1.001 millivolts. So back to the spreadsheet, I'll just shut that off. Right shunt reading 1.001 millivolts, and I convert that to the corrected value in amps by using the 1.0011 calibration value, and that gives me values of the actual current, and then you can see the errors there are very small, and that's in percent. So quite a remarkable device for $27, and if you need to extend the range of your multimeter's ability to read current, this will go all the way to 30 amps, 15 amps continuous, and 30 amps for, what does it say, 15 minutes maximum. So yeah, I'll get some heating in this device, so you wouldn't want to do it for an extended period of time at 30 amps. But in any event, quite a nice little device for $27. And that's it. Thank you for watching.